So many scientists say that the world is 4.55 billion years old. The thing is, they're not using the scientific method. There's been a change in the culture, in our institutions, in the media, in the government, in academia. 4.55 is a number that everybody likes, and they don't want to change it.
The personal implication of where we've come from can mean something very important.
Absolutely. This is not an academic thing. Where the age came from, how speculative it is, makes a huge difference for us to be able to really understand where we fit into the world and our purpose for being here.
Didn't radioactive dating prove that the Earth was billions of years old, not thousands of years old? How can any rational person say that the Earth is 6,000 years old when the age we're presented with in all of our culture, in all of our major institutions, is 4.5 billion years old? How can so many people be wrong? Dr. Tas Walker, you're a geologist who has studied extensively in the area of radioactive dating, the age of the Earth, and you actually believe that the Earth is around 6,000 years old. How can so many people be wrong?
Well, the reason is that people have different starting points. That all comes back to where you start. And we see that the age of the Earth is different from science. And so I think it's be really good to look at how scientists measure time and see that when it comes to the age of the Earth, it's not really working that way. So when you're measuring time, for example, and scientists do it a lot, it's very, very important in science, is that, well, you could think of a athletic race, a 100-metre dash,
okay,
for
so
example.
an example.
So how do you measure the time that takes for a guy to run that race? So the way they do it is they have the starting blocks and they've got a guy with a gun. This is the way it used to be. And it's still done this way in many situations. But they have the guy with the gun there at the starting point, and then at the finishing line, the timekeepers are there. And so they're watching the gun, and as soon as they see the puff of smoke, they start their stopwatch. And that's because they do it when they see the puff of smoke, because it takes longer for the sound to get to them than it does
seeing the smoke.
And so they could be out by a quarter of a second or something like that if they didn't use the smoke. And so then when the race ends, they stop the stopwatch and they've got the time. It's as simple as that. And it's the ending time minus the starting time. That's how you calculate the time scientifically, scientific observations. There's a problem, though, is that if the guy keeping the time misses the start, then he can't get the time of the race. So that's why you have at least 2, maybe 3 timekeepers. And so there's multiple measurements, multiple observations. And you know, the various associations, they've got sort of rules worked out on what you do in different situations. So they want to make sure that the observations and the recordings are done properly. So that's how it's done for a 100-metre race. And it's basically, that's the way scientists keep time. That's basically the scientific method: observation and recording, recording by multiple people. And so that's how it works.
Okay, that's the scientific method.
Yeah, and do the same thing with your age. It's a scientific method.
Okay, another example, yeah.
How do you know your age? Well, you know the day it was born, when you were born.
Yep.
Do you remember it?
No.
You don't.
But it's written down.
Yeah, well, who wrote it down? Your mother was there at the time. And probably a doctor or a nurse, someone like that, and they would have recorded it in the birth certificate. And so you can calculate your age because you've got the starting time, the birth certificate, you've got the time today, so you can work out how old you are.
Okay.
It's really simple. It's actually, I have got a friend who he says his mother insists that they got the wrong date in the birth certificate. And so that is, so that's quite an interesting little situation. And you can't rectify that because, you can't go back and check it.
No, he'd need a time machine.
Need a time machine. And interestingly, it comes up occasionally that things come before a judge to try to sort something out that happened in the past. Like there might be a crime that's committed and somebody has to come and it has to be, work out what's true and who's guilty and who's not guilty. And so, interestingly, the Bible says how it gives instructions, or it gives a way of knowing how to decide that situation.
Okay. What does it say?
Well, how do you decide what happened in the past? And it says that one witness is not enough to convict a person of a serious crime they might have committed. You need 2 or 3 witnesses. And that's basically the scientific method, 2 or 3 observations. And that's the way it works. It's the same with time. And we could go to other examples. Another really good example is, for example, you've heard of Napoleon. I've been interested in Napoleon, reading about what he did. And the Battle of Waterloo, he lost that battle. And you can work out how long ago that happened. And it was a particular date in 1815. It was a Sunday afternoon, actually. I think it was the 18th of June, I think it was, that it happened. And so you simply take that date, the starting date, from the present date, and you can work out it was about 210 years ago. And the starting date, so how do we know that? Well, there were thousands of people there.
Thousands of observers.
Thousands of observers. It was written down and recorded in history. And so that's a date that we know because people were present. And so the same thing, it's like a scientific method to work out the date of when things happened in the past. So that's how we know how things happen.
Before we continue, a quick heads up. Stick around until the end of the interview because we'll be offering a free ebook, the Creation Answers book, which is packed with biblical answers to over 60 of the most asked questions about creation, evolution, and the Bible. You won't want to miss it. Now, back to the interview. So the scientific method is being used to observe multiple times and then to record what has happened.
And then, as you said before, the age of the Earth, scientific, so many scientists say that the world is 4.55 billion years old. So how can scientists be wrong? The thing is, they're not using the scientific method. The age of the Earth is not based on science because when you think about it, who was there? Who saw the Earth form? What date did it form so that we can calculate how old it was? So because it's not observed, it's not really science. So how do you figure out how old the Earth is?
That's a big call, Tas. A lot of people would be very unhappy to hear us discussing the fact that this is not based on science. These dates are supposed to be scientific. That's the way they're taught.
So how do they work out a date for it? I'm going to go through and have a look at how this has evolved, this particular date has evolved over many, many years to come up with a number. But the thing is, it depends on what you believe about how the Earth formed. See, we didn't see it happen, so we can speculate about how it came about. And basically the modern thinking in geology and science and that sort of thing is that everything happened by naturalistic processes. It all happened by itself. And so that's the mindset that's around today.
It's like a worldview.
It's a worldview, that's right. And so if you start with that worldview, you get, there's various ways that people think, well, maybe it formed like this, maybe this happened, and maybe that happened. So how did we get the core? Well, maybe, so where did all the bits come from? So that people are sort of speculating as to how it could have all formed. And so over a period of time, these views, these speculations, these ideas have changed. And so the way the Earth formed has changed in people's minds. And so what that means is that the dates and the age has continued to change. It's a very interesting journey how that's changed, particularly over the last, 100 years. Just before that, the beginning of the 20th century, and just before that, the age of the Earth was very, very much a debated issue.
Okay, I want to look at this today, Tas, because as we're saying, this is very significant if we're challenging a paradigm that is taught now in present day everywhere. My students in my classrooms will often be asking if we look at things like the geological column, if we look at fossils, textbooks, everything's telling us this much older date, this 4.5 billion years. I want to look at how we have got to this. When I have students saying to me, but aren't these dates scientific? Surely if so many people believe them, they must be true. Can we unpack this today?
It's really a matter of knowing a little bit about what science is. And we see the amazing things that science has brought about in our culture, travel in space, cell phones, computers, electric light in the house, automatic things. The amazing things of science have brought us, and people think that, well, how can these things not be true? But science is about observation. You could call it experimental science. You could call it observational science. It's about making observations. And that's what I had to do when I did my work as an engineer and studied the flow of fluids in pipes. I would make observations, and I'd have to repeat the observations. And I'd compare my observations with what other scientists had done in other parts of the world. So that's what science is about. But when it comes to geology, now that's a very interesting situation because you can observe the rocks in the field, and that's what geologists do.
Yep.
They look at what's there, they can see what rocks are sitting on what other rocks and what the rocks are made of. And
that's
the
observational
colours.
science.
That's observational science. And geologists are very good at this. They go out into the field, they're all dressed up with their boots and their documents and that, and they're recording it on maps and
They've got
things.
scientific instruments.
That's exactly right. That's what they do. And so they record this, and one of the ways it's presented is in a geologic column, and which is like a chart.
Yes, we see this in the science textbooks all the time.
That's right. And people think it must be true. Well, it generally is true. It's based on observation and what geologists record, and they have recorded the various fossils that they find in the rocks.
Okay.
And they can work out which ones are under which other ones. And so this chart has got the fossils at the bottom are the oldest ones, the ones that are buried the deepest. And then as you go up, so you get things like clams and trilobites, and then you get fish and dinosaurs in this geologic column.
And that's based on observational science?
Based on observation.
Those layers, the order of things appearing, etc.?
That's right. Okay. And they give them labels so that they can be able to discuss them. They've got different, like you got the Cambrian and the Triassic, and you've got the Jurassic and all that. Yes. They're all given labels and based on documented where they were found on Earth, Jura Mountains for the Jurassic and that sort of thing, the Cambrian in Wales. So it's based on observation of geology.
Okay. But my students will then point to the dates at the start of the table.
That's right.
These are those dates that we're talking about that are so much older than the worldview we were mentioning you have of 6,000 years.
That's exactly right. So on the dates on the side of the column, like it starts down the bottom, one of the first ones you see is 600 million years. But actually the beginning of the Earth is 4.5 billion years down there. And then it goes, there's fish 300 million years and the dinosaurs 100 million years. You've got these dates along the side. So the chart that's presented is a mixture of observation and fact and philosophy. And so where do these dates come from? That's an interesting question.
Yes.
But they don't come from the fossils. When the geologist finds a fossil, it doesn't have a little date on it which says I'm 100 million years old. He finds a fossil, and it might be a fossil of a dinosaur bone. And so he can identify that dinosaur bone is similar to another dinosaur bone found somewhere else. And so he sort of thinks that, it fits there. And he looks on the chart and he sees where it is on the chart, where the dinosaurs are, 100 million years. So he reads it off there. So there's a mixture of fact and this philosophy. So where does the philosophy come from? It actually comes from a guy who lived in Scotland. His name was James Hutton. He was a fellow that started this. He was a doctor, a physician, and he loved rocks. He loved going out into the field and looking at rocks, and he wrote a book called The Theory of the Earth. And in it, he set up a philosophy for how to work out the ages of the rocks. You see, that's the problem. We can see the rocks now. How did the rocks form in the past? We can't go back in time to see them. That was the problem with geology. As a matter of fact, a lot of people said that geology is not a real science. In physics you can observe things, and in chemistry you can observe things, but in geology you can't go back and look at the rocks when they formed. And so a lot of people didn't want to call it a science.
That's interesting to know about how the sciences have progressed in history as well. We look at that table and it's very convincing for our students in our classes, for anyone perhaps, because you've got those layers that are based on observational science and the dates next to them. So it's so, I guess, tricky, confusing perhaps for a student when it presents as if this is all observational science in front of you. The dates are right next to observational science. But what you're telling me, Tas, is that actually there is an element of observational science, but there's an element of
philosophy. Assumption.
Okay.
Yep, that's exactly right.
That's
And so
significant.
where does the assumption come from? And it comes from the question as to how do we know what happened in the past and how can we explain the geology? So that's where it comes from.
Okay.
And at the bottom of this chart, of course, is the age of the Earth. So the age of the Earth is there right
That's
at the
our
bottom.
starting point for
That's the starting
that
point.
worldview.
And so then all the other ages that are there, they sort of divvied up so that it makes a nice gentle progress down from the present time to the age of the
And
Earth.
when this column was formed, was that 4.5 billion, etc., was that already in place?
Well, actually, it wasn't.
Okay.
When it formed, people, well, you know, when this started out, people thought the Earth was about 6,000 years old. It wasn't even 6,000 years old. James Hutton, he lived in the late 1700s, and he's the guy that came up with the philosophy. And so his idea was, well, we can't go back and look at the rocks then, but we can look at the rocks now. We can see what's happening now. So what we'll do is we'll use what we see happening now, and we'll say that that is what happened in the past. So that's the philosophy. And as if it's, it makes good sense. But there's a big problem. For example, it doesn't take account of a huge catastrophe in the past, which is described in a historical book, which is called the Bible. People think it's a religious book, but it's actually got a huge amount of history in it. And so this global catastrophe, which the Bible describes, Noah's flood, had a huge impact in the past. And so James Hutton, by saying we're going to use what we see happening now, we don't see global floods happening now. And so by not taking account of that, he came up with the conclusion that the world must be unimaginably old because there was no catastrophe. So that's where the age came from.
But even if, Tas, there wasn't, let's say many people don't believe there was a global flood, isn't it also not taking into account a whole lot of other possibilities of things that could have happened to impact the geology of the Earth anyway? So even if you don't believe there was a global flood, this idea of, well, the present is how we're going to measure the past, it's still probably not taking into account a lot of things that could have possibly happened.
That's exactly right. And you need to have that philosophy in order to be able to work out a system.
Yes.
And if you just allow for catastrophes to happen, then you really can't get a nice even system. So at the beginning, it was like the rule of the Medes and Persians, the law of the Medes and Persians. It had to be slow and gradual, and no catastrophes were allowed. No meteorite impacts were allowed. There just had to be slow and gradual, like the sort of things that we see happening today. So that's the way it started. And James Hutton is a Scottish guy. He was the guy that started it out. And
was he a geologist?
No, he was a physician. He was he loved geology.
Yes.
But at his time, I read a book about him, like a biography of him, and it said at that time, everybody believed that the world was about not even 6,000 years old. All the different churches, the Lutheran Church, the Anglican Church, all the different churches believed it, the Catholic Church.
So it was a much more common worldview to believe the biblical account.
That's right. And not just the churches. Everybody believed it. It was just part of the culture. So like today, the idea of 4.5 billion years is part of the culture. Back then, the idea that the Earth was the biblical age was part of the culture.
So culture has changed somewhat drastically then.
That's right. There's been a huge change in culture. And the interesting thing is that first edition of the Encyclopedia Britannica, it actually talks very seriously about Noah's flood. It's got an artist's impression of what the ark could have looked like. It's got a table of the ages of the Earth. And in this table, it says that the Earth was created about 4,007 years before Christ. It's got that. So Encyclopedia Britannica,
very
the first edition.
different age range to the current paradigm.
That's right. And so what has happened is that there's been a change in the culture, in our institutions, in the media, in the government, in academia. All this has occurred. And today, because that's the culture, anybody who's presented with something different just thinks that's crazy. So I think that's what is happening with the students in your classroom, is that they're just so absorbed in the culture. And so you've got a really interesting task to be able to sort of help them to see things from a different perspective.
They are presented with so many powerful images and messages. They only have to walk into any of our museums, and the 4.5 billion years is everywhere. So is this why, because our culture is so steeped in this now, this is the predominant worldview, is this why so many people hold to this age?
Absolutely, that's why it is. And most people think it's the only thing that they've ever heard.
Yes.
And so they think it must be true. And so it's really interesting to open them up to the other possibilities. But this 4.5 billion years is not something that was just arrived at like that. The geologists, when they started out, like James Hutton, and there were others in the early 1800s, they didn't really know what the age was. All they knew was it was unimaginably old. And they needed eons and eons of time to be able to use present processes to explain everything. That's where the age came from.
Tas, why do you think they were changing the most predominant worldview at the time, which was around 4,000 to 6,000 years? Why were they having to come up with something different that had so much more time?
Because they wanted to come up with a scheme in which they were able to explain everything by naturalistic processes. So it's naturalism. You could call it atheism.
Without God, without God. Intelligent designer.
See, when you start with the Bible,
Yeah.
and as I said, that's you can regard it as a history book, it starts with a supernatural creation at the beginning. So there was 6 days that God created the world in. And that's not ridiculous when you think of what God's like. You know, God is all-powerful. He's all-knowing. He's wise. And so he's quite able to do it. So it's not a ridiculous, self-refuting sort of idea. It's quite consistent with the Bible.
If he wanted to, he could have just done it like that.
He could have done it in 6 seconds rather than 6 days. So it doesn't refute itself. It's a consistent worldview. And so that's what people believed at that time. So when they were looking for these eons of time, they had the idea that we will be able to explain everything by naturalistic processes.
Okay.
And it seemed very positive. Of course, they didn't know if they could. They were just thinking that we think that we will be able to if we start with naturalism. We don't need anything supernatural. We'll be able to explain it all. And there's been lots of problems, of course. It's been, how long has it been? 200 years since then, over 200 years.
Okay.
And you would think it would be solved by now if it was solvable, but it's not. There's still the same problems which were back then are the problems which are unsolved now. For example, one of the ones is, we've got living things on the world. Where did life come from? And life comes from living things. Like you have life, it produces life. But in this idea of naturalism, you have to have non-living things which produce life.
Why do we have to have that, Tas?
Well, where do you get life from if you've only got non-living things at the beginning? And so that's how the people who believe in naturalism, that's what they believe, is that at one point in history, non-living chemicals have become turned into a living cell, self-replicating living cell. So that's naturalism, but what I'm just pointing out is that there are lots of problems with it.
Yes, well, I feel like even one of my 12-year-old students could probably easily say, but life produces life. You can't get non-life producing life. We know that. We observe that.
So that's just an example. And one of my colleagues has written an article called 5 Atheist Miracles, which is about, some of the problems involved in describing something or explaining something by naturalistic processes. So it's not been solved, gives the impression it's been solved, is presented as if it's solved, and all the coloured, diagrams in the books and that give you the impression that it's all there,
yes.
But it's not. And so from the very beginning, there was a problem with the idea that we need eons of time. And there was a guy who's a very famous physicist who developed the concepts of thermodynamics, which produces refrigerators and heat engines and electricity.
Okay, who is this guy?
This guy, he became known as Lord Kelvin, but his name was William Thomson. So he was a very famous guy.
What time period are we talking?
We're talking about in the sort of second half, 1800s, that sort of period. He's sort of towards the end of his life at the end of the 1800s. So he did a calculation about the age of the Earth. And so being a thermodynamics, he assumed that the Earth was initially a ball of molten magma.
Okay.
So that's what he assumed at the starting point for the Earth. And then he did his thermodynamics and calculations and that to calculate how long it would take for the temperature of the Earth to cool down until it's eventually the temperature it is today.
Okay.
So that's what he figured that out. So again, you have to have assumptions. What was the Earth like at the beginning? And so he made a guess about what it was like. Actually, it contradicts what the Bible says. The Bible says that at the beginning that the Earth was covered in water. So it was never a molten blob. So we didn't have a problem with it cooling down. It was created at the beginning suitable for life. But that's what Lord Kelvin assumed.
Okay.
And he came up doing lots of calculations. He has to assume the initial temperature. He has to assume the sort of emissivities and the various conductive things and all that sort of thing.
Things he couldn't observe because he wasn't there.
He wasn't there. He has to assume them. And he came up with reasonable values. And he eventually came to the conclusion that his opinion is that the Earth is somewhere between 40 million years old and 20 million years old.
That's much younger than 4.5 billion.
That's right.
Huh.
So, which is a lot older than 6,000.
Yes.
But it's so, and so that's sort of, 40 million is a big age, and that was all published, and it was all in the newspapers, and so people get the impression that it's really old.
And what were scientists saying about Lord Kelvin's?
Well, the scientists didn't like the number.
How come?
Can you believe that? They didn't like it. Well, the geologists, they needed much more time. But see, the problem was they couldn't argue against Lord Kelvin because he was so clever in thermodynamics and equations and differential equations and all that sort of thing and doing the calculations. And once you make the assumptions,
right,
it just comes out.
Okay, so if they're not questioning those starting assumptions that he was making, well, then he has so much credibility in his field.
That's right. That's right. And so that's what happened. And so the geologists were very unhappy about it. And basically there was one guy, I've forgotten his name now, but he sort of said this, which is a typical of what the geologists said. They couldn't argue against him. They didn't want to accept the number. So they said, perhaps someday something will be found which is able to explain why it didn't cool as quickly as Lord Kelvin said.
Okay.
So that's an appeal to something in the future. It's faith. We believe the age is older. And so we will, someday something will be found. And, in some ways, that's not that bad an opinion, because if their assumption is right, then that's quite reasonable for them to sort of say, I don't believe it. And that's what we do. We believe the Bible is accurate.
Yes.
And so when they come up with an age of 40 million or, 4.5 billion, we say, well, we don't think that's right. because the history of the Bible records 6,000 years, and so that's what we're going through. And so what creation scientists do is they look for reasons as to how to explain the evidence within that worldview. And so that's what this geologist did. He said basically, Chamberlain was his name, and he said, well, maybe something will be found someday. And so the geologist wouldn't accept it. But there are other people that didn't accept it either.
Okay, other different types of science fields.
So you've got thermodynamics, you've got geology, two different fields, and then you've got biology. And so biology talks about where all the living things have come from after you get the first living cell, and that's Charles Darwin.
And they didn't like the dates either.
Darwin didn't like the dates. He would write to some of his colleagues, and he talked about Lord Kelvin, about how he was really stressed by what Lord Kelvin had written, and because he couldn't answer it either. And he says, I need a great amount of time before the Cambrian for my theoretical considerations. So he needed lots of time as well. So you've got a problem with the biologists. And so then what happened was they discovered radioactivity. That was in the late 1800s. They discovered that there was radioactivity, which produced heat. And so everybody jumped on this. Aha, that's it. That's the answer.
How is that the answer?
Well, the idea is that inside the Earth, there's these radioactive elements, and they are producing heat.
Yes.
And this heat is stopping the Earth from cooling, as Lord Kelvin assumed, and so it can be unimaginably old because of radioactivity.
Okay.
So
they would have felt like they've got the answer now.
Yippee!
Okay.
That's right.
And what happened to us?
Well, they jumped on it. It's a game. You see, it's really a game where people want a certain answer, they want a certain conclusion, and they jump on it even before they do the calculations. And today, it's well known that there's a lot of problems with radioactivity explaining the age of the Earth. It's not as simple and doesn't work out the way they assumed. But it was like a political coup. Kelvin was defeated. We've got the answer that we want. Everything's good. So the physicists were not. They were reasonably happy. The geologists were happy. The biologists were happy. So everybody was happy. And then what happened is that radioactivity enabled people to measure the radioactivity in a particular in a rock, or in a mineral. And so they figured out that if you can do that, you could calculate the age by making measurements of the radioactivity in these rocks. And that's what they did.
Without making any assumptions?
Well, they did make assumptions.
Okay.
They assumed initially there was none. There was none of this stuff to start with. And so they assumed... In the rock. And that's a whole nother story, but they did have to make assumptions. And so they started doing calculations. And there was a guy by the name of Arthur Holmes. He was actually the son of a minister. And he got into the geology, and he's written geology textbooks and things. But he started doing analyses on rocks, and he'd come up with an age of, 200 million years. And he'd published this.
Yep.
And people were just so interested in it, 200 million years older than what Lord Kelvin said. And so do that. And then he'd do another analysis on another rock, and he'd get 600 million years. And so the age was creeping up, and everybody was astounded. Nobody knew how it was done. Radioactivity was just so mysterious. And so people were just buying into this amazing, understanding that the Earth is older and older than we can imagine.
You could see how it's seeming like it's all based on observational science.
That's
as
right.
opposed to, no, there's some science here, but there's also some assumptions about the starting point.
That's right. The same thing with the age of the rocks. It's assumptions about the starting point. Now, a very interesting thing happened is that as the age of the Earth started getting older and older, 1,000 million years, 2,000 million years, and then it became...
So this is what's happening. It's actually changing the dates.
They're changing the dates. You see, they didn't just calculate and get a number. It's going up and up, and then eventually it was getting that the age of the Earth was greater than the age of the universe. Isn't that incredible? So the age of the universe, that's based on the Hubble constant, and the Hubble constant, and this guy Hubble, a great astronomer, he was terribly prestigious, and he had calculated this constant, and that's how you figure out the age of the universe. And he was saying that there's no way this constant could be changed from what it is. We know exactly what it is. And yet these young geologists were coming up with ages older than the age of the universe. And so there's a great big bun fight developing there.
Oh, my goodness. So what happened? What was the result of this battle?
Well, the astronomers had to give in. They gave in and they said, oh, yep, the Hubble constant's actually larger than we thought. And so they got an age of the universe. Currently, it's about 14 billion years old now for the universe. And so that's the way this particular stuff went, as far as figuring out the age of the Earth. And people think, well, how did they actually figure out the age? And
it's amazing to hear the changes in ages, the arguments about this between the different scientific fields. It doesn't feel reliable.
It doesn't really feel like reliable science, does it? When you make measurements, it doesn't matter who you are, whether, what religion you are or anything like that. You make a measurement and everybody gets the same answer. And that's what we do when we study science and do scientific experiments. We all get the same answer. And if we don't, then we can figure out where we've gone wrong.
Yes.
And so that's what happened. And so, well, how did they get the age of the Earth? Well, it was a guy called Clair Patterson. He was a geochemist, and he calculated the age by measuring some isotopes of lead, and he would plot these on a graph, and he got a straight line. And so you can work out these isotopes of lead. They could measure how long it takes for radioactive decay to occur, and so they can work out the time of that. They plotted on the graph, and from that graph, calculated the age of the Earth to be 4.55 billion years, plus or minus 0.07.
Oh, it's quite detailed.
Quite precise.
Right.
And so that's what he published. And that was 1956. So that was when the date came out. And a lot of people said, that's ridiculous. You've done it the wrong way. And you've used the wrong things. Well, you'd think if you're going to calculate the age of the Earth, you would use rocks which came off the Earth, wouldn't you?
Yeah.
Guess what he used?
What?
He used meteorites. Meteorites. And that's what other guys said. You can't calculate the age of the Earth from meteorites. And he said, oh, yes, you can.
What was his reason for doing it?
He said, because that's how the Earth formed. See, he's making an assumption about how the Earth formed. Well, he didn't assume that. That was what, geologists and the cosmologists were thinking about the formation of the solar system. They came up with this idea that the Earth was formed by meteorites or broken pieces of rock coming together and forming the Earth, and then that's how it all happened. So he said that basically these meteorites, they're exactly the same as what the Earth's made from. And so that's why he used meteorites. He produced this line. He did some analysis of seafloor sediment to show that the seafloor sediment, the lead in it, was the same as what the lead is in the meteorites. And so based on that, he said this is the age of the Earth. There was a bit of an outcry about it because of those assumptions. And one guy, Holmes, who I mentioned, he said it's wrong in principle to use meteorites when we don't really know if they are connected with the Earth at all.
So he's recognising those assumptions.
He's recognising that. But he had the analysis of this seafloor sediment, and so it carried the day. For the 4.55 billion years. And it's interesting that I think since that time, the number hasn't changed. So from the year about 1900 up to 1956, the age of the Earth went from 20 million up to 4,550 million in 50 years. And I know Arthur Holmes said, about how the age of the Earth had been gone multiple times bigger than he, and in his age, just in his work, what he'd been doing on it. So it's very interesting.
And then it stopped, and it hasn't.
And then it hasn't changed.
Okay. Why hasn't it changed now?
Hasn't changed. Well, if you're talking to the people who advocates of the science, they will say that's because we've got the right answer.
Okay.
And, they make a really good argument for that. It's a bit like politics. One side says this, the other side says that. So they will say that's because we've got the right answer now and we know it's right. And I would say, no, I think it's because there's been a huge change in the culture. It's changed from a culture which basically believed the Bible back in the sort of, the community. Most people believed the Bible. It was the academics who were pushing this naturalistic idea. But most people believed the Bible back in
population for a long time.
That's right. But it was persistingly changed, looking for a naturalistic explanation. So a naturalistic explanation for the thermodynamicist, 20 million years is fine, but not enough for the geologist. So the geologists need more time. And that's not enough for the astronomers. So every discipline was trying to figure out naturalistic explanations. And so they were looking for ways of getting a number which everybody was going to be happy for. And I think, in my cynical way, I think any number between 3 billion and 7 billion would have been fine for the age of the Earth. Any number in there, that would be enough time for all the geology and all that. It's be fine for the astronomy, anywhere between 3 and 7. 4.55, that's ideal. And also you get it so precise. And so that's why I think the number hasn't changed. And it's sort of become a little bit embedded that it's going to be very hard to change it because, generally people are quite happy with it now. And their naturalistic explanations seem to work, but they don't. But they're reasonably happy that they can work within that.
I hope you're enjoying this interview so far. Creating content like this takes a considerable amount of time, effort, and resources. We're passionate about getting this message out, and we want to keep bringing you more videos like this one. But here's the thing, we need your help to make this happen. Your support, no matter how big or small, will help us cover our production costs and enable us to continue creating impactful content. To support this project, just use the link in the description below or the on-screen prompt. We're so thankful for your support. And Tas, are there scientists today that are finding there is evidence against the solid date that we have now? Are they coming up with evidence that suggests that's not right? Are they bringing that up? Are they talking about it? What happens when they do?
Well, there's an interesting book. A geologist by the name of Cherry Lewis, she wrote a book called The Dating Game, in which she outlines the whole of this history of it was about Arthur Holmes, and it was about how the age of the Earth and all the stuff that happened on that. And as a geologist, her colleague said, look, don't call it the dating game, because it makes it, but it is a game. It was, as you can see.
Sounding like that.
Sounding like a game. And in her foreword, she said, look, I apologize to anybody who found this in the romance section. But she called it the dating game. Anyway, so in the dating game, she sort of says about the Clair Patterson. She says that the conclusion is that his assumptions were wrong. The seafloor sediments he analysed, more work has been done, and rather than falling on one nice little spot, they spread all over the place. So you haven't got the sort of confirmation that these meteorites actually fit with what the need is on the Earth. Plus, as people have been trying to figure out how the Earth formed and the idea of where the Earth's core came from, that has changed. The scenarios that they've developed for the formation of the core now are different. And so his assumptions no longer apply there. And she said, it seems like Clair Patterson, he was lucky. He got the right answer, even though he made the wrong assumptions. And I think that's really classic. It just shows that, 4.55 is a number that everybody likes and they don't want to change it no matter what the evidence is. So don't tell me any evidence. That's what we're going with.
That sounds a bit dangerous that we might even be ignoring the evidence today. would you say, to because we don't want to challenge that date range?
Oh, exactly right. But a lot of people think that the age of the Earth is not that important. Although I do hear about people that say that the age of the Earth, that when you understand where the Earth's come from and how old it is, it gives us an impression of where we fit into the scheme of things, and just it helps us to understand our purpose and meaning as to why we're here, just by understanding the age of the Earth and where it's come about. So they're looking at naturalism, and naturalism really doesn't give you much comfort about
I was going to say, where do they say that means they fit in that worldview?
But they don't actually say, but they do say that it by understanding that, it helps us to understand the universe. But it doesn't. As you say, Arthur Holmes, he did some work in Mozambique, and he wrote home to his parents, and he said, when you look at the stars, he says it makes you think about just how meaningless and pointless the whole of this existence is.
Meaningless and pointless.
That's what he said, and a lot of people experience that. When you think about the scientific explanation as to where we came from, that we evolved over millions of years, we came from apes, and before that we came from non-living chemicals. So that affects the way we think about ourselves. And there's a sort of a label given to this sort of idea, which is a sort of a very black and depressing idea, and that life has got no meaning, and what's my purpose, particularly when people get a little bit older, they start to think about how transient life is and how quickly it moves, and that sort of thing. And so it's called nihilism, this blackness. And it's only when we understand that, in fact, what the Bible says, that it is indeed a created world. This whole thing has been made. It's been made for a purpose, and that people are a special part of that creation. And that's what makes the whole difference. So I like to say this is not an academic thing, but basically it's personal. It affects us personally. And so understanding where the age came from, how speculative it is, what sort of thinking it's based on, makes a huge difference for us to be able to really understand where we fit into the world and our purpose for being here.
So the age of the Earth is actually very much tied to, even if you say, I don't really care how old it is, 4.5 billion, whatever, it's actually really tied to where we've come from, and this idea, as you're presenting, of having beginnings that are intentional or beginnings that are just a result of naturalistic assets.
That's right. Richard Dawkins puts it this way. He says, we live in a universe. See, he's an atheist, doesn't believe in God. He believes in the naturalistic explanation. He says we live in a universe which has no design, no purpose, no meaning, nothing but blind, pitiless indifference, which is a very, very black sort of way about it. And one of his colleagues, a lady from Somalia, she rejected, she grew up as, from a Islamic background, and she rejected that and became friends with Richard Dawkins. And there was a team of these guys. Dawkins, they called himself the four horsemen of the apocalypse, and quite a number of them have died now. But so Dawkins is still alive, getting on, but she experienced this blackness and this darkness in her life, and she was looking for an answer. She was depressed. She would drink a lot. She said, I drank enough alcohol to disinfect some huge hospitals. And she went along to various counsellors and psychiatrists and people like that. And one lady who was sort of a counsellor with her, she said, Ian, she said, I think you are spiritually bankrupt. And she went on about how she hated God. And she said, but that started her on a journey to actually, she's become a Christian. And it's been very interesting how she has had a conversation with Richard Dawkins. It's recorded. It's been recorded and it's available to watch, about Richard Dawkins saying something like, he said, he said, but God is just obsessed with sin. And she said, well, I'm a new Christian, she said, and I don't know a lot, but in my experience, it's an obsession with love. And I found that God is obsessed with love, and that brought her out of her depression. So you see, this whole issue has huge impact on us personally.
Yeah, not just from an academic point of view, not just from understanding science, but also very much the personal implication that where we've come from can mean something very important.
Absolutely.
And we've got a resource that we are giving away as a free ebook, haven't we, Tas? The Creation Answers book.
Yeah, that's a great book.
Can you tell us about it?
Yes, it answers 60 of the most asked questions to do with the biblical worldview, to do with science, things like geology, biology, the origin of life, cosmology, those sorts of things, plus a whole lot of questions that come up to do with Noah's flood. That's a brilliant book, and a lot of people think that's great.
So this free ebook will be available with a link in the description below. Tas, thank you so much for your time today.
It's great, Jess.